program and instruction cost is also a worry of code generator. What do you mean by cost? Cost of executing an instruction. Power consumed for an instruction. Memory required to keep an instruction. So all these are cost measures. How much time it will take for compilation? See, cost measures, length of compilation, size of the target program, running time of the target program, and power consumption of the target program. See, this is cumulative. Power consumption of a target program is sum of the powers required to compute every instruction. And in the introductory chapter of our module 1, I had given you a hint about this discussion. I had given you even a hyperlink which discusses about generating power efficient codes. I don't know whether you have looked into that. So all these are criterion for code generation in the code generation phase. Now, who will calculate this? Code generator will have to calculate this. See, when a machine is developed by a company, like say Intel CPU or Motorola, they will also publish a manual for that CPU. In that, they will meticulously write everything. What are the clock cycles required for every instruction? And from that, all these associated things can be arrived. So everything will be documented by the CPU manufacturers. They will not. They are not producing the machine itself. They will produce how the machine can be used. Now, we have to determine the cost of compilation and running a program. And that is termed as a NP-hard problem. See again. And if you see the entire compiler theory, you can see that either it is NP-complete or NP-hard. Many of the problems in compiler design. That means you have an active scope for research and further exploration in this paper. And this paper as such, you cannot just take a slice of bread called as compiler design and work with that. It is an interdisciplinary topic where inputs will be taken from various fields. And now we are in the era of anywhere, anytime computing in the AI arena. So people who work and think, they have a lot to do in this area. So wherever you see NP-hard and NP-complete, complex problems like that, you see that people have not stopped working there, telling that they will develop heuristic techniques. They will develop heuristic techniques, and these techniques will produce some good results, but they are not optimal. So if you can make a result which is good than good, you have a scope. Always already a lot of good results are produced. Suppose that I can produce a result that is better than all good things. It need not be optimal. Still, it will be accepted. After PG, please don't shut down your research work. Even if you're working, suppose that you do your own business also, you can have a branch of things like research. You can at least give a light to your juniors or the next generation. Suppose that you continue to work this area, you have a lot to do in all these areas. So carefully see, after PG main worry is where to go. MPhil is getting stopped. Now PhD remains as a next step. So carefully we have to see, we have to evaluate our weakness and our strength, our attitude, and then we have to land up in an area also. Here we have a small discussion on computing program and instruction cost. It depends upon the way memory are to be accessed. We know that when we have operands, we have memory locations and GPRs. GPRs are part of CPU, so nil cost will be recorded for that. Whenever we have to access a memory location, cost will increase. So cost corresponds to the length in words of the instruction. Here, if registers are there, then zero additional cost will be computed. If the addressing mode involves a memory location or constant, both we have seen memory location and constants. We can use constants. We can also use memory locations. In that case, additional cost of 1 will be added. Why? Because such operands have to be stored in words following the instructions. Now we will see how this is being done. See LD R1, R2. Here, value of R2 is lowered to R1 or copied to R1. Here, the instruction is having a cost of 1. Since R1 and R2 are registers, primary memory is not getting accessed, so the cost is 1 for this load instruction. Whereas LD R1M, here M is a memory location. So this memory location is to be added. Here the cost will be 2. Since first the memory location called M will be accessed, then that value is to be put back to R1. See here LD R1 star 100 R2. Here R2 will be taken for value of R2 should be added to value of R1. Then we will get a memory address. Then that address will be looked up. So the cost will become 3 because constant 100 is stored and after this we have 100. So we have these many operations to be done. Here it is R2. So this is how the cost will be calculated. So you may be given a piece of 3 address statement or machine address code. Then we may be asked to compute the cost of instructions. This is how we have to compute that. We may give we may be given an intermediate piece of code, and we may be asked to produce the machine instructions using these LDs, store, STs that I have discussed. So in all these cases, in the ways knowledge we have acquired today can be tested.